So this video is going to focus on double angle, half angle, and sum and difference identities. So you see that across the title here. And those are located on your trig identity sheet. If you haven't downloaded that and printed it off, you should. It's in Canvas, I think in a couple different modules. But it's definitely at the top of the analytical model or module. And right here are the sum and difference formulas. Here's the double angle identities, and there is the half angle identities. And there's the Pythagorean identities that you should already be familiar with, because we've been using those in proving trig identities. So these are this formula sheet you'll be able to use on the final or on any test or quiz that we take. So you really want to print it off and start using it to get used to it, get used to where things are, so you can find things easily. And really, the more you play around with this, the more these formulas will become familiar. Even if you don't memorize them, which I don't recommend you take time to try to memorize them, but if you use them over and over again, they'll become more and more familiar to you, and you'll be able to recognize them right away. So anyway, you want to keep this out next to you when you're watching videos, the teaching videos, or when you're working on homework, or when you're working on take-home quizzes or whatever. You want to keep this open so you're using it all the time, so it'll be familiar with you. Okay, so let's go back here. So what do we do with these double angle, half angle? Well, they're actually useful in a lot of different ways, but the way we're going to use them is in this class is one way is we're going to find exact answers of non-friendly angles using combinations of friendly angles or using right triangles. Those are two different types of problems we're going to be using these with. Then you're also going to use these identities to solve trig equations, and you can also use them to prove trig identities, the things we've been working on most recently. So I'm going to give some examples of this first one on these first two on this video. In fact, I don't know since how long it goes. I might just do this first one here and then come back and do another video for the other one. So how do we use double angle, half angle, or sum and difference formulas to find exact answers of non-friendly angles using combinations of friendly angles? So, for example, if I'm trying to find out what the cosine of 15 degrees is, let's say. Okay, that is clearly not a friendly angle. However, twice that is a friendly angle. So if I'm thinking about the half angle formulas, right here, half angle identities, notice this starts with the sine or cosine or tangent of something divided by 2. So the first move I'm going to make here is I'm going to rewrite this as cosine of 30 divided by 2. And we all agree that 30 divided by 2 is 15. Okay, so if we set that next to the half angle identity, it looks like this. You could see in this scenario, theta is 30 degrees. Okay, because we have a 2 there, a cosine, and the only thing that's left is a theta and a 30. Okay, so we're saying in this run of the half angle formulas, we're going to let theta be equal to 30 degrees. So then when we if we look at the half angle formula, it says that this is equal to plus or minus the square root of 1 plus cosine of 30 degrees, because it says theta there, right, over 2. And notice all that's inside the square root. Now the first point of possible confusion is there's a plus or minus there. Now plus or minus does not actually mean plus or minus like it does in the quadratic formula. Remember, in the quadratic formula, plus or minus means both of those are answers. But this really means the formula is basically saying to you, I have no idea whether this is positive or negative. You need to figure it out. And the way we figure it out is we go back to the original question and we look at this. So if I'm asking for the cosine of 15 degrees, I know that 15 degrees, even though it's not a friendly angle, I know that 15 degrees is in the first quadrant. And what do I know about the sine of cosine of something in the first quadrant? Well, it's positive, right? So that means I can drop these two symbols and know that the answer is positive, because I'm taking cosine of something in the first quadrant. Okay, so that takes care of that. So then we just go ahead and simplify this. So I have the square root of 1 plus, and of course we all know that the cosine of 30 degrees is the square root of 2 over, whoops, no we don't know that, is the square root of 3 over 2, and then I have a little 2 on the bottom. And of course we got a fraction within a fraction, which that's not considered simplified. So we need to simplify this. And so my answer is the square root of, so the way I would simplify this is I would multiply top and bottom by 1/2. That'd be one way to take care of it, because that would leave me with just 1 on the bottom, which means that I don't need it anymore. And on the top, I'm going to have 1/2 plus rad 3 over 4. And since I have two fractions, I can add them together. So I'd get a common denominator. So that'd be 2/4 plus rad 3 over 4. And when I combine those, I get I get the square root of 2 plus square root of 3 over 4. But wait a minute, I know what the square root of 4 is. So I can finally write this as 2 plus the square root of 3 divided by 2. Because I took the square root of 4, and that's why. So now notice the 2 is not inside the square root bar anymore. Okay, so that's an example of using the half angle identity. But I'm going to go back and look at this problem again from a different perspective. Okay, so let's say that I didn't realize that 15 is half of 30, which is, I know that's a big stretch because that's pretty easy to realize, but let's say instead of thinking about half angle formula, I'm thinking about the sum and difference formula, which says, if we look at that baby real quick, that's these guys. If you have a cosine of something plus something, you can rewrite it this way, which looks more complicated, but the problem is right now I have cosine of a non-friendly angle, so I can't do it apart from a calculator. But if I'm trying to use the sum and difference formula, I could rewrite this as the cosine of 45 degrees minus 30 degrees. And you can see that now matches up with, sorry about switching back and forth here, that matches up with this guy right here, cosine of something minus something. And so in our new scenario, the A is 45 and the B is 30. Okay, so if I hop back over here, whoops, not there, if I hop back over here, we're comparing this to the cosine of alpha plus beta, right? No, I'm not. Alpha minus beta. And you can see that alpha would be 45 and beta would be 30. So then another way to write this based on the formula is the cosine of 45 minus 30 degrees, that is equal to cosine of 45 times the cosine of 30 plus, I'm just looking at the formula now, I'm pulling it off, sine of 45 and sine of 30. And now notice that all those are friendly angles, so I can do them in my head. Cosine of 45 is 1 over rad 2. Cosine of 30 is rad 3 over 2. And sine of 45 is 1 over rad 2. And sine of 30 is 1/2. So then that would be rad 3 over 2 rad 2 plus 1 over 2 rad 2. Of course, they already have a common denominator, so I can just add them together. And I get the square root of 3 plus 1 over 2 rad 2. Now, those of you that are alert and paying attention, it seems like we got different answers here, didn't we? And we should have got the same answer because in the beginning we're just evaluating cosine of 15 degrees, right? So why are these two answers different, or why do they seem like they're different? Well, because we used two different techniques, and we didn't actually simplify them the whole way, really, because I have a square root within a square root here and a square root in the bottom. So are these actually the same thing? So just so that your heart is okay and settled, I want you to take out your calculator right now, along with me, and I want you to type those two things into your calculator. So this one, you're going to write parenthesis, square root of 3 plus 1, close parenthesis, divided by, parenthesis, 2, square root of 2, close parenthesis. And over here, you're going to go square root of 2 plus square root of 3. So all that should be inside parentheses, and then do a little divide by 2. And see if you get the same answer. Okay? So I'm going to do that right now. And you do it also on your perspective calculator. And for the first one, I get approximately 0.9. Come on, Dale. 0.9659258, etc. Now if I do the second one, I'm going to take the square root of 2 plus the square root of 3, and all that is divided by 2. And once again, I get approximately 0.9659258. It's the same, exactly the same. So you can see that these, even though they don't look the same, they are the same answer, which is a great relief, because if we took the cosine of 15 using one technique and then took the cosine of 15 using a different technique, we should get the same answer. And we in fact do. So that's 2 examples of using these identities to find exact answers of non-friendly angles using combinations of friendly angles. Okay, so I think I'll end the video right now. There'll be a bunch more of these. There's a worksheet on the module that runs through a bunch of these, and I will be posting a video of me working through that worksheet, so that would be a great place to go and try that out. And then I will make another video on using right triangles. All right.